Welcome to the 9th installment of Ear to the Ground, the Land Stewardship Project's audio magazine podcast. Ear to the Ground features interviews, reviews, and field reports related to sustainable agriculture, family farming, local food systems, and local democracy. I'm your host, Brian DeVore, editor of the Land Stewardship Letter. What benefit does farming produce for society? Food, right? Sure, but there are indications that diverse agricultural production systems can produce a variety of positive benefits for society that go beyond just full grocery carts or barges brimming with grain. In this show, we're going to take a look at a concept called multiple benefits agriculture. During the past few years, the Land Stewardship Project has been working with farmers, rural communities, university researchers, federal and state agencies, and other organizations to determine what multiple benefits farming can produce. The Multiple Benefits of Agriculture Project, as this research initiative is called, has come up with some exciting results. Some of those results were published in a recent issue of the scientific journal Bioscience, and they've caught the attention of researchers and policymakers working on how agriculture, economics, and the environment interact. The Bioscience paper describes a modeling study involving two Minnesota watersheds, Wells Creek in the southeast and the Chippewa in the west. The analysis showed that farming systems which rely on perennial plants such as grass while incorporating hay, small grains, and other resource-conserving crops could significantly improve water quality. What are we calling significant here? In the southeast, Minnesota watershed studied, the amount of eroded soil or sediment present in the water dropped 84% when fewer annual crops such as corn and soybeans were planted and more perennial plants such as grasses and hay were present on the land. The western Minnesota River system saw a 49% drop in sediment when more perennial systems were added. Pasture grasses and hay can produce economic benefits for farmers by being fed to livestock such as cattle. So this study not only shows that more year-round vegetation is good for the land, it also provides good evidence you don't always have to take land out of production to get positive environmental results. In other words, farming systems on working lands that utilize soil-friendly techniques can produce positive ecological impacts while generating economic activity for farmers and the communities that support them. That, in a nutshell, is one example of how farming can produce multiple benefits for society. I recently talked with George Booty about multiple benefits agriculture and the research that was featured in Bioscience. Booty is the executive director of the Land Stewardship Project and one of the authors of the paper. We throw around this term multiple benefits of agriculture. If you could just briefly explain to the lay person, what does that concept mean? It's kind of getting an international, I'm hearing about it more, not just here in this country, but overseas as well. Maybe you could talk a little bit about that.
Sure. The basic concept is, I think most people think of agriculture, they think of food production or maybe fiber of one kind or another. But really when you think about it, growing crops on the land or raising animals on the land has lots of different impacts and potentially lots of different benefits. Before I directly answer the question on multiple benefits, I just want to say that we started this study with a base of monitoring on a number of individual farms in different watersheds, mostly in southeastern Minnesota over a number of years. And we worked with the University of Minnesota, with the farmers themselves and state and federal agency people and private consultants. And we were tracking the changes that happen on these farm fields related to birds and what kinds of songbirds might be reproducing and being observed on the land, what kinds of fish and organisms that grow in the bottom of stream beds grow. What were they and how were they changing? What was the shape of the stream bank? What kind of soil quality, and what was the soil quality, and how was that changing? So we were looking at a whole variety of things, as well as family quality of life concerns, and so all of these are examples of the kinds of benefits that can come from agriculture. Normally people think of agriculture as producing food, and it certainly does, and we want it to, and other kinds of fiber that you might wear and so forth. But really agriculture can do many, many things for us, and private lands in this country are the majority of lands. The water that needs to infiltrate into our soil and that runs off to our streams or lakes is affected by farms, at least in this part of the country, and it's particularly affected by farms. And so we want to think about what kinds of agriculture do the best job for producing clean water from their farms. They might also be able to store carbon in the soil. That's a pretty popular concept right now. There's a lot of concern about global climate warming, and one of the ways of dealing with that is to hopefully store some of that carbon we're releasing. Some kinds of agriculture might be able to do that or help with that, and that's an example of a benefit. There are benefits to the community by having farms that have products that are processed in the community and that are bought and sold in the community. That can be a great benefit. And obviously the more people on the land, the more needs there are for clothing stores and schools and more people to go to churches, and it's all of those things that it takes to have a functional rural community. You need people to be part of that. So farms can either help support that or detract from that, depending on what kind of farm operation and what kind of farming system in total is going on.
So when you went about trying to study the multiple benefits that farming could produce, you picked these two watersheds. They weren't picked by accident. The ones in southeast Minnesota, ones in western Minnesota. Wells Creek is in southeast and the Chippewas in western. Can you explain the difference between these as far as the type of farming that's going on in the areas and the geography?
Yes, well, the Chippewa watershed in western Minnesota is relatively flat. The average slope is something around 2%. And it's in the northern reaches of the Corn Belt. And so the principal crops that are grown are corn and soybeans with some sugar beets as well. And about 80% of the land base in that area is in crops. And about 80% of those crops are corn and soybeans. So it's pretty homogeneous in that sense. Whereas in the Wells Creek, that's a much steeper watershed. It's on the banks, really, of the Mississippi River and near upstream of Lake Pepin. And there, about 60% of the land is in crops, and the other land is already in more grass cover or forest. And the crops that are being grown, while they're still principally corn and soybeans, are more diversified. Partly that's true because there's more dairy operations still in that watershed, and a dairy farm typically has more diverse crops that go into the feed source than those farms in the west that are growing their food primarily for grains and selling it as grains, or that are providing food to hog operations.
And can you take us through the way this, it's a modeling study, and the way it was set up is you went through scenarios, and you kind of looked at what would happen to the landscape if we switched a little bit more, a little bit more, a little bit more from the current farming system. So can you just take us through what those scenarios look like?
I can, and I should say too that we convene citizens and farmers from each of those areas. Actually, in Wells Creek, the citizens had already been meeting, and so we talked to them about what they'd like to see for the future of their area if the policies and so forth could be changed and overcome. And then we tried to take those ideas and mold them into scenarios that we could then test through this modeling. And basically those scenarios were, of course, one is just no change. And one is the more of what's happening now, which is a movement toward larger and larger farms, toward fewer diversity of crops, toward adding more soybeans on the acres and less alfalfa and that kind of thing. So that wasn't a big change, but it's a current change in the direction. Another scenario then involved what we call best management practices, and those are practices that are designed to be used within the current existing cropping systems, the dominant cropping systems, and they're designed to reduce as much as possible the damage that might happen to water and other environmental systems from those farms. So the best management practices we looked at one has to do with tillage. There's more conventional tillage, which involves more turning of the soil. And then there's what might be called conservation tillage, which is less stirring of the soil and then also leaving more of the residue from the dead plants on the surface of the soil after the end of the growing season. And those things protect from water running off as quickly as it might otherwise would do. And so best management practices involve tillage. They involve following the recommendations for the University of Minnesota as to how many nutrients, fertilizer nutrients are applied to the crops and when they're applied. And then the third is to buffer all of the streams with 100-foot wide grass buffers on either side of the stream. And so those are three things together would be the best management practices scenario. The third scenario, and this was one that people from the watersheds were interested in more economic diversity, because I think many farmers and others recognize that they're pretty dependent on a relatively few crops right now, and they'd like to see some more diversity into the system. So when the markets go bad for one crop or another, there's a way of dealing with that. One of those kinds of systems, for example, might be an organic production system, certified organic, or other kinds of alternatives as well. So we then looked at what would happen if we could convert the acreage to a crop rotation that included 5 crops instead of basically 2. Mm-hmm. So in addition to corn and soybeans, you might have some small grains and a couple of years of hay. So that was a change. And we also then looked at, historically, where were the wetlands in these areas? Where would they be most useful in terms of capturing the runoff and storing water and being productive from an environmental standpoint beyond that? So that combination of looking at a 5-crop rotation and including best management practices in all of those crops, and then wetland restoration. And then the fourth scenario was saying, well, what would happen if we would take the higher slope lands and put them into some kind of grass that could be used to produce food or fiber? So one way of doing that is to feed cattle from a pasture situation. Another might be to harvest that perennial grass for energy production, or to grow it for seed, to plant prairie seed along highways, whatever. Some different options, but to use the land, and then looking at what would happen if we had 300-foot buffers around the streams. So that's fairly long.
Yeah.
None of these scenarios were prescriptive. They were what-if scenarios. What might it look like if we could do this on a landscape basis across the watershed? So those are the scenarios.
A big part of this, or a really main character in all this, is the idea of perennial plant systems. Can you just give a simple explanation of what kind of, when we're talking about watersheds like this in the upper Midwest, what kind of perennial plant systems are we looking at that would be getting established on the landscape?
Well, there's first to think about perennials, you're thinking about cover on the soil. So when you have a bare soil, that's when you get runoff, that's when you get erosion, that's when lots of problems happen. So the goal is to keep some type of plant material growing on the soil and covering the soil for as much of the year as possible. In annuals, usually you're planting in the spring, and they begin growing then. They don't really grow fully until July probably, and then by October they're pretty well dead or dying. So there's not that much of the year in a strictly annual cropping system where the soil is really fully covered.
Right.
In a perennial system, there's a couple of ways of thinking about that. So if you're growing corn or soybeans, you might be able to grow a cover crop in between the rows. That would grow all year, or at least for most parts of the year. So effectively, the soil is being covered almost all year. That's one thing, and we did look at that as part of our scenario D. And then another way of thinking about perennials is that you actually plant plants that grow for 2 or more years. So alfalfa is an example of one of those kinds of plants that grows for several years, and then you harvest it, and then it grows back again. There's a variety of different kinds of grasses. And again, cattle, cows and beef animals particularly, their stomachs are designed to be able to digest cellulose. That makes up a large percentage of the plant material in grasses. And so they're perfectly attuned to eat grass.
Right.
In fact, of course, that's what they evolved to eat.
Rather than grain.
Rather than grain. It's only been in recently that they've been fed large or toward the end of their life more principally on grain. That's a fairly recent phenomenon. So grass can be grown and harvested in rapid succession. And for raising animals, one of the best ways of doing that is called management-intensive rotational grazing or planned grazing. There's different names for it. But basically, you're taking a number of animals, keeping them on a fairly small area of land with movable fence, and letting them eat that grass. But, if you think about a golf course and you think about the tee, that grass is extremely short. In a well-managed pasture system, the grass never gets that short. It's left longer so that it can regrow very well. And the cattle themselves are providing the nutrients, so you don't necessarily have to fertilize, and certainly not extensively. But anyway, so perennial plants, so those are different examples of perennial cover.
And not to oversimplify it, but one of the results of the study or the conclusions was that the more perennial vegetation on the ground, the better the water quality. And in some cases, it was pretty dramatic. Like in the Chippewa, there was a 49% reduction in sediment, or the amount of eroded soil that was in that stream as the amount of vegetation went up. And in the Wells Creek, it was as much as 84% reduction in that sediment. Mm-hmm. Which is great. This is a modeling study. How do we make that more of a reality? How do we make that an actual reality? Or why don't we have more perennial, vegetation on the ground? And how can we bring that about and go beyond just here's a great scenario into making it a reality?
Well, it would take a number of different kinds of changes. It would take changes to policy, changes in the kind of research that we do, changes in what we choose to eat and how we market those products. So there's a number of changes that would be required in order to move more significantly toward even a diversified system. Because there's a lot of benefits even when you diversify, even if you don't go take it all the way to a perennial cover. Farmers are growing corn and soybeans principally in this part of the country because that's really what we have as society have asked them to do. We've told them to do that. Right. We've sent all the signals to them. There's a part of our federal farm program that's really constitutes our nation's food policy, pays people based on how much they produce of certain crops. And included in those crops are corn and soybeans, and then there's others such as cotton and so forth. So the more they grow, the more they might receive from the government, at least when times are hard. So it's like an insurance policy,
right? And
you tend to gravitate to what you're insured to do.
Yeah.
And in addition to that, at the same time, our universities historically have done a lot of research on corn and soybean crops, and much less on how we use grass more and more effectively to produce animals, what the protein content should be and how to grow it and so forth. We've just done much less research. The companies that are the big companies, the grain companies like to buy and sell corn and soybeans, and it's in their interest to have as low a price as possible, and that's gained from having as much production as possible. So they benefit from that system. And the big seed companies invest more of their research and marketing efforts in those plants that are going to make them the most money. And so all these things feed into each other. So farmers have an excellent marketing system for corn and soybean. They have a lot of research behind them, and they have insurance policies through the private sector and through the public sector, and they have commodity programs. And so there's a lot of reasons why people are growing what they're growing. And we've decided also now that those crops are the principal feed crops for our animals. So for cattle, instead of what might be called growing them on grass for their whole life, or finishing them on grass, we finish them in feedlots, and that's feeding them primarily corn. And even for dairy cattle, we're adding more and more corn into the diet, or as part of their diet, rather than moving in the other direction.
And that means that you can have a situation, say in the Chippewa, where you've got corn and beans, where you don't need to have the livestock right there, because you can raise the corn and beans and then ship it
to California, for example, where there are a lot of big dairies in California, and they don't grow corn in California last time I looked.
Yeah. So if you have more of a situation where you're reliant on grass-based systems to raise that livestock, you can't economically ship that grass to California, or they have to be there to graze it. So it requires to have livestock in that watershed, it sounds like.
That's right, and on the land, not just in buildings. I mean, if you put livestock in buildings, you can theoretically put those buildings anywhere you want to.
Right.
But if you're trying to raise livestock actually with literally crops that are growing, and they're out harvesting those crops themselves, then they need to be on the land. So
it sounds like what you're saying is having more livestock in these watersheds would be good for water quality, which isn't always what people... They don't always associate good water quality with livestock.
Well, that's what we found in this study. We hypothetically increased the number of livestock. We doubled the number of cows and beef cattle in the Wells Creek watershed for the purpose of this modeling study. And despite that fact, the water quality would dramatically improve if we could move to that kind of scenario. The one thing that wouldn't improve as much would be greenhouse gases, because cattle produce methane, and that's one of two in particular greenhouse gases that are of primary concern. But now, this part of the country had animals on it for a long time.
Right.
The prairie evolved with animals. There were antelope and buffalo and other big ruminant animals. So it's not new to the area. It's not new to the Earth's ecosystem, but it might be new in one specific area.
Right.
Again.
Yeah. Well, people often these days, if they think of livestock and water, they'll conjure up images of cattle standing in a creek or in a lake and defecating, urinating in it, and that type of thing. There's a lot of negative images that come up.
That's right, and that certainly is not a good thing. From our monitoring work in the past, we did look at the whether or not cattle could be grazed properly in the stream bank area. And we found in some former prairie areas that you could actually do that. And when you compared that to upstream areas where there was inappropriate grazing, where they were just allowed access to the stream anytime they wanted, or in another stream where you actually had removed the cattle and it had gone back to box elder trees and some other kind of weedy tree species, there was a favorable comparison between having cattle with an occasional access to the stream corridor and excluding them in terms of the shape of the banks and the water quality in the stream.
Often when people talk about the idea of conservation farming, what they think of, and what's been supported by government agencies like the NRCS, is putting in place a terrace or a grassy waterway, some type of structure or some type of best management practice, such as if you're raising corn, do minimum tillage to reduce the amount of soil that's disturbed. And the idea behind this is to prevent further degradation of the environment. It sounds like what we're talking about here is something a little different in that we're actually saying that some farming practices can improve the environment, not just prevent further degradation, prevent a certain amount of soil going into the river and kind of get us at a plateau there, but actually improve it. That there's situations where the water could leave that farm in better shape than when it came in at the other end.
Absolutely. That's exactly it. And that's where this idea of multiple benefits comes in. Is some of those benefits are that we can grow food and or fiber and perhaps energy also at the same time that we're achieving other enhancements to the environment. So if grazing is done, there's been studies in Wisconsin and in Minnesota that show that if you do rotational grazing in a way that's sensitive to breeding birds in the early and kind of midsummer, that it can be done well, and you can get both animal production and birds. So that's an example of where that's an enhancement,
right?
Because we're for songbirds that were reliant on prairies, they're declining in large numbers, in part because their habitat up here in this part of the world is declining, and so. This is rotational grazing could be one way of providing more habitat on the landscape. Same for streams. We can have food production, we can have animals, and we can have improved water quality actually in streams and high water quality. And we can we can reduce greenhouse gas production because we can reduce nitrogen fertilizer use. So there's a lot of different benefits we can get, not just from grazing, but from diversified cropping systems.
The next Ear to the Ground will continue our discussion of multiple benefits agriculture by examining how diverse farming systems can benefit the aquatic residents of a watershed. We will also look at how one scientist's perceptions of how farming relates to the environment have changed as a result of his research on working livestock operations. To read the bioscience paper referred to in this podcast, see the Multiple Benefits of Agriculture and Pasture-Raised Livestock webpage at www.landstewardshipproject.org/programs_MBA.html. That's landstewardshipproject.org/programs_MBA.html. You can scroll down to the first peer-reviewed paper. You can send your comments, criticisms, and suggestions about this podcast to me, Brian DeVore, at bdevore@landstewardshipproject.org. That's bdevore@landstewardshipproject.org. You can also get me on the horn at 612-729-6294. A special thank you goes out to Laura Borgendale, a Western Minnesota musician and LSP staffer who provided Ear to the Ground's theme music. And a very special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member and would like to support us, go to landstewardshipproject.org to learn how to join LSP. Thanks for listening.